This is just to talk a little bit about energy, to introduce energy to you. Um, and there's a little bit of humor here because energy is defined as the ability to do work. But later on, I'll define work as the ability or the transfer of energy. So it's a little bit of humor. It's a circular definition to be sure. Energy is an abstract concept, but this is how I think of it, right? Energy is basically what makes things go. Okay, the food that I ate is heating my body. The energy that's in gasoline makes your car go. It makes it do work. The energy stored in your iPod battery when you charge it up makes it do all its little iPodness things, right? Okay, so that's the concept, right? Is that things that go a wind-up toy. When you wind it up, you store energy in it, and it uses that energy, right? Okay, energy is used up, and by this I don't mean it's destroyed. I just mean that we fill our tanks with gasoline, and it's used up. Our laptop computers need to be recharged. It's something that's used, right? Um, and then it's once you figure out how to calculate energy, and I'll show you how to do all these things, right? That quantity is neither created nor destroyed. Okay, so all energy that you got from someplace, and when you no longer have it, something else has it. It just moves around, and this is why it's really pretty cool because we can look at a ball, rolling down an inclined plane, and we did you look at it as like mg sine theta and all the forces and calculate the acceleration of it, right? But or if a block slides down the plane, really it's just got potential energy here and it turns into kinetic, and it's a very simple calculation. So that's why we're going to be calculating that, right? And then it's mostly nuclear. This is a challenge, and we'll do this in class because it's much more fun. I can't hear you from here, right? But you'll probably think of some examples of energy. So come to class with examples of energy that you think are not nuclear, and I can show you that they probably are nuclear. Okay, not too many examples that aren't. Okay, there are types of energy. There's going to be one, two, three, four here. The first one I've got is electromagnetic energy, energy of photons. Um, and right after the Big Bang, of course, that's all there was a bunch of photons whizzing around. All the matter you see around you is actually just condensed energy. So energy and matter can turn into each other. This is Einstein's big thing, right? Okay, is that some amount of energy can become matter, and matter can become energy, and the speed of light squared is the constant, right? This is a very big number. So a small amount of mass, right, can turn into just a tremendous amount of energy. And we'll talk more about that, next year when we talk about nuclear reactions. Um, but yeah, that's one type, right? The next type is potential energy, right? So this is energy of position, stored energy. Some examples of this is like gravitational. If I take a box and I lift it from the floor to a shelf, right, it's got more energy up here than it does down there. Chemical energy, right? If I've got two hydrogens and oxygen, right? And I light a spark, right? Well, I release that potential energy. This is one position, right? And I can get some water and a lot of heat energy released, right? Or I could have a spring, and if I stretch the spring, right, some length, it's got energy stored in it. It wants to go back to that position, right? So wind-up toys use that. So that's potential energy, and we'll look at how to calculate different kinds of that. And then kinetic energy is energy of motion. Objects that are moving can do work. For example, a hammer, right? A swinging hammer. You can drive a nail into a surface, right? Hit it with the hammer, and it's moving, right? Because it's got those little lines after it, right? When that thing hits that nail, this thing's kinetic energy actually pushes that nail in there and does work on it, right? Baseball, traveling baseball has a ton of energy in it. That's why you want to wear a helmet when you're around a fast-moving baseball, right? And then our final one is thermal energy. It's the random potential and kinetic energy of molecules and atoms, right? And I've got a little thing here that's there it is, right? Okay, I like my examples. They're hot stuff, right? Anything that's hot has thermal energy. Really, this is just, it's not a special type of energy. It's just potential and kinetic energy. You can think of these molecules. I mean, concept zero, a hot object the molecules are vibrating really fast, right? This is a solid here. You can think of these guys as being joined by little springs and wobbling back and forth on those little springs. I can draw all the springs here. I got to draw them all, right? Okay, boy, those last few springs got kind of... But you can think of them jiggling back and forth. When they're moving fast, they've got kinetic energy. When they've compressed the spring and they're all ready to, bounce back the other way, they've got potential energy, right? The reason that it's that we tend to talk about thermal energy as a different type of energy from these guys is that it's very random. There's certain laws that we have in thermodynamics about turning this kind of energy into those kinds of energy. Okay, and that's all you really need to know about energy.